Very much, and good afternoon, dear colleagues. First, I would like to thank you, Sultan and Andrea, for inviting me to present at this meeting. In this presentation, I will talk about the new production system called Fiber, which is built on GSIM and will be used in the production of national accounts. Okay, next slide, please. So there are many interesting areas to explore regarding the role of GSIM in this Fiber system, but we only have limited time here, so we have to focus on a few selected topics. And first, we will take a look at the statistical program design and process design from the business group of GSIM, how we have implemented that. That is, I would say, a key area to get for the Fiber system. Secondly, we will take a look on how data sets and their role in the production process. And finally, I will show a set of slides that illustrate an outcome of a trial using a graph database for visualization of the data sets and the production process. So it's with all the metadata being produced, we can actually view everything in a graph database. So this presentation includes numerous slides and detailed images. So unfortunately, I don't have time to talk very deep in some of them. Okay, we can take the next slide. Yeah, as I said, the business block in GSIM is a very important part in Fiber, and this is where most of the user interfaces are and where we create our workflows. So you can take the next slide, please. There. So here is a selection of from the business group in GSIM. And I have marked some of the crucial objects with red circles, but when I did that, these mark here make like a impact on the user interfaces that we are going to take a look at right now. So next slide. So we will take a look. We will look at the user experience and how it maps to GSIM. So here in the left menu, you have like the main navigation. So at the top of the tree, you have the statistical programs. And for the national accounts in Sweden, they have, I think they have decided to divide national accounts in 7 or 8 statistical programs. I'm not 100% sure because they are implementing things as we speak. So, but I think there is about 7 or 8 statistical programs, and underneath each statistical program, they each can have multiple statistical program designs. And you can, of course, you can copy a design and start copy a design to a new one and start editing it. And typically in the you can stay. Go back one, please. You can go back one there. You can stay there. So I say next slide. So and you can in the national accounts, they often have like a design for each type of quarter one, and then they reuse the quarter one for 2022 and 2023, and so they have multiple designs for each statistical program. And then you have, of course, the process steps and the process design. Okay, you can take the next slide. Okay, there. In GSIM, the process step has a circular reference that enable us to build like depth, like in GSPPM we have the 4.1, and then we can do 4.11 and go deeper. So this is a key finding that we in GSIM is that in the description of process step, it says at some level it will be suitable to view a process step as a distinct divisioning. So this is very, very, very important for the behavior of this system. You can take the next slide. So what we see here is data specifications. The dataset specification represent one dataset that will be created inside this process step. And behind every dataset specification, there is one task and one data structure. So you attach in the design, you select the type of task, and then you provide a data structure. So this is very, very important. You can take the next slide. Okay, this is, for example, it begins with these import tasks. So in the national accounts, I think they have about 300 incoming data sets, and underneath every one of these, there is a reference to a provision agreement from the exchange part of GSIM. So they set up exchange provision agreements on all of these deliveries of data sets that they're coming in. Okay, we can take the next slide. So this shows how to read these arrows. So you can say that in order to produce the dataset transformed raw data, we need the input. It depends on raw data. And for the next one, final observation registers, it depends on that we have transformed raw data, and so on. So these and these arrows, I would say they are can take the next slide. This is one type of task, this mapping, and what you do in this, we can do transcoding. So there is a rule behind here that the user set up with the rules of how to transcode the incoming raw data to an output data structure that this dataset specification holds. So we have an incoming data structure from the raw data, and we have the data structure that we want out. And behind, in the middle there we have a rule that describes how the transcoding will take place. This is the idea that we are having these mappings in a specific type of task is that we want to have a clear view where these transcodings are being done. Typically, they are done in the input processes, and also you can do some transcoding when we are doing dissemination to different, for example, IMF. Then they have specific codes could have that is a little bit different from the ones that we have inside the production. Okay, you can take next slide. And then we have tasks that are VTL, that performs and executes VTL code, and we can also use SAS code. So we can execute SAS code with VTL instruction eval. And someone told me that at least 80% of the calculation done in the national accounts, where they will do it with VTL, and then there are some processes that need SAS. Okay, you can take the next slide, please. Yeah, and here this export task. Here you can see at the form these task. There is of course a data structure and a task behind here. That is they perform an export, so we can we can transfer the data sets to, for example, databases for publishing or dissemination, and we also can send this data set for creation of the SDMX files. Okay, we can take the next slide. Yeah, this is just an example of how this final data set looks like. We have a data structure that is corresponding to the DSD, and then we have the data points in, and this is very nice to do conversion to SDMX from here. Okay, you can take the next slide. Up here, we have the different types of tasks that we have. There aren't that many, but these are the ones we have identified and what we need. We have the ones that I just described, but you can also add like dataset specification for validation, the yellow one here. We have a very specific way of do validation. And so we will perform the conval and struval validation locally inside this Fiber system on these datasets that are at the end before we are making the transformation to SDMX. We will perform. We can copy the VTL code from struval and conval and execute them locally. GUS adjustment. This is when we need to add manual adjustments. There are cases and there are a special handling in these cases when we do manual input. And T is very special. I will talk about that one a little bit later. This is the key type for national accounts. Okay, we can take the next slide, please. Okay, this is more how it looks like right now. We have also support in Fiber to generate reports and perform analysis. I think that the subject matter people will need even more and powerful tools for analysis, but at the moment they are satisfied what we have built in, but for sure we will need to enable more powerful way of do analysis. I'm pretty sure that they will. And reports and can be done against the subject matter people design their own reports, and they can point at any data set inside the design, the production flow design. Okay, you can take the next slide. Now we can come into how we are transferring data sets and storing data sets in this system. Well, let's see. You can take the next slide. This illustrates that we have different business services carrying out the different tasks defined in the process design, in the process steps that we have designed. For example, in this image, the data set that is a circle around, it has reference to 7 other dataset specifications. So when data is coming in, these tasks underneath start execute automatically. So validation starts, and then there is a icon indicating, okay, now we are doing validation of the incoming data through the provision agreement. When that is done, the transcoding kicks in, and there is a process that they're indicating that this being processed. Then when all 7 of these green mappings are green, okay, they are executed, then the VTL that starts doing its job of doing some VTL calculation. Okay, we can take the next slide. Yeah, this is not that much important. We have like services that manage that to read data sets and store data sets, and and yeah, create new data sets. It's not that you can take the next slide. See the next slide there. Yeah. This is a little bit more on this one. So this provides an illustration of how the whole system actually operates. So, but we have to ensure consistency, Fever is using our newly developed system for metadata called Mink. So we have one single source for code list and classifications and valid domains, etc. And we see some of the GSIM objects from the structure group at the bottom. You can take the next. Okay, we are adopting this idea of steady states, or that I think it was New Zealand or that wrote a paper a long time ago. I read where they described something called steady states, or quality gates, as someone called them, or checkpoints. So some of the data sets, because there are thousands of data sets being produced in this system, so some of them are like labeled that you are a part of a steady state or a checkpoint or quality gate. So we have identified. I'm not going to go into that deep, the different types of steady states we have identified. We can take the next slide. Okay, this slide is very, very important. I will see if I can try to explain what's going on here. Each data set has like an URI or a path, you can say. So the data sets have a statistical program and the statistical program cycle and the data set name. So for example, in financial, or they have some kind of statistical program for the financial part, and then you have like the production cycle for quarter 2023, quarter one, and then you have a data set name. So they are accessible from all over the system by these relative paths. So you can access, we don't want to have any hard-coded references to time. So we set the time on the statistical program cycle, for example. Yeah, the T is set on the set. And then when you want to reference data sets, you do it by navigating by T-1, for example. Then you want the data set from the same statistical program that you are inside, but from the previous statistical program cycle. And this is all over the place in the national accounts. They are reading and doing a lot of analysis and between the previous version of data sets. So this is, so you can see that the T reference, the dataset specification, is more like a proxy or a pointer to a dataset in another context. Very powerful and very, very important. Okay, we can take the next slide. Okay, I'm going to show just they made a demo of all these data sets and all these metadata being created. They made a demo with a graph database called Neo4j. Can we see, is it possible to get the next slide? Yeah, there we are. So this is actually a data sets from one statistical program cycle, just a portion of them. So this is, and here you can see, we can take the next slide. Each circle here has its origin from one of these dataset specifications that we made in the design, in the statistical program design and the process step design. So each dataset specification has become a dataset in the dataset catalog, you could say. You can take the next slide. And here, this wasn't included in the demo, but of course we can access the data points that's inside the data set. Can take the next slide. Can take the next there, and of course also we can find the rule, like the VTL code used to produce this data set also. Okay, you can take the next slide. And what happened actually here is that these process input specifications is now in the when data set has been created, they are now process input. So we can see, for example, doing one of these circuits, we can see what data sets has gone into the task behind this one to produce and this gives data an incredible provenance, you know, because if you, for example, take the table 1, I think it's called in the transmission program, the main aggregates, and then you can actually, it will take you a long time and it will probably lead you in a lot of different ways, but you can step by step move towards like the input data sets, and you can follow all the 300 and all the VTL scripts being but this is the test, just a test we did with this Neo4j graph database, and we'll see how we will use it. It's not our main focus right now to work with this more, but it's very interesting. And the reason we can do this is, of course, that we are following GSIM very strictly, and we don't cheat, we don't skip any of the objects, and all the relations then fit together. And we can, there is actually another part of this schema, I don't have any, you can mark a code list, and then you can see in what data sets does this code list exist. So the selection anyway was included in this demo. Okay, next slide. I think that was the last one, and I hope you got some idea of how we are using GSIM. One of the toughest part was to figure out the business process design. The process step design, and how to find out that at the lowest level we have this task. It becomes a task. Once we figured that one out, a lot of things played out pretty natural, I would say. And at the moment, the national accounts are implementing all their calculations and all these process flows, all these process steps. There are a lot, really a lot of it, and all this VTL code. And but it looks very, very beautiful. Almost like me, like I'm a layman in I don't know national accounts, but if I sit with them and they show a process step and they show the data set specification and the naming conventions, and it's sometimes, and then you can look at the VTL code, and it feels just for a moment that you understand what they are doing actually. So it's really amazing documentation, and it brings a clear view of all their calculations being done. But there's a lot of work from the subject matter to use all these structures to map it, how they could take use of all these ways of structure thing, and what data set specification should we have. So it's a huge task they have taken on them to do. Okay, I think that's all for me. Thank you.